Good afternoon, children. So, in the previous class, we already discussed about probability, right? So, probability, the chance of an event is known as a probability. The chance of an event is known as probability. So, it has two types. One is empirical, another one is theoretical or experimental or empirical probability. Experimental is nothing but empirical. Okay, so it has two types. One is experimental probability, another one is theoretical probability. So experimental or empirical probability of an event is based on what has actually happened, while the theoretical probability of the events attempts to predict what will happen on the basis of the certain assumptions. Yes, as the number of trials in an experiment go on increasingly, we may expect the experimental and the theoretical probabilities to be nearly the same, right? Yes, so the chance of an event is known as probability. So the difference between experimental probability and the theoretical probability, and also we discussed about a formula to find probability. So there is a formula, the theoretical or classical probability of an event E can be written as P of E is defined as P of E is equals to number of outcomes, number of favorable outcomes divided by total number of possible outcomes of the experiment. Yes, where we assume that the outcomes of the experiments are equally likely, right? And also we discussed about sure event and impossible event. So we know that the probability of a certain event or sure event is 1. The probability of an impossible event is 0. That is unsure. That is yes, the probability of an impossible event is 0, and the probability of an event is a number of P of E such that 0 is less than or equals to P of E is less than or equals to 1. That means the probability of an event which is lies between 0 and 1. So an event having only one outcome is called an elementary event. The sum of the possibilities of all the elementary events of an experiment is 1, right? An event having only one outcome is called an elementary event. The sum of all the probabilities of all the elementary events of an experiment is 1 for any event, that is P of E plus P of E bar, which is equals to 1, where E bar stands for an not E, and E bar are called a complementary events. So complementary events can also be written in P of E plus P of E bar, which is equals to 1, right? And also, yes, here we have a question that is see that question, a piggy bank account contains 100 50 paisa coins, 50 rupees 1 rupee coins, 20 2 rupee coins and 10 5 rupee coins. If it is equally likely that one of the coin will fall out when the bank is turned upside down, what is the probability that the coin, right? So we know that the chance of an event is known as probability. The chance of an event is known as a probability. So we know that the probability of an event is equals to number of favorable outcomes divided by total number of possible outcomes, right? So yes, it is see here, a piggy bank, like undi. Okay, a piggy bank account contains 150 coins. This is 150 coins and 50 1 rupee coins and 22 rupee coins and 10 5 rupee coins. If it is equally likely that one of the coin will fall out when the bank is turned upside down, what is the probability that the coin will be a 50 paisa coin, will not be a rupees 5 rupee coin, right? So come to the solution. So first of all, we need to find the total number of sample space, that is n of s. Here we have a sample space that is total number of coins in a piggy bank. So 100 rupee 150 paisa coins, this is 150 paisa coins, and 51 rupee coins, and 20 for 2 rupee coins, and 10 for 5 rupees coins, 5 rupees coins. So total number of coins in a piggy bank, so 100 plus 50 150, 150 plus 20, it is 170, 170 plus 10, we get to 180. So the total number of coins in a piggy bank is 180, that is total number of sample space, total number of sample space, isn't it? Yes, children. Next, we need to find the probability of getting a 50 paisa coins, right? Yes. So the probability of getting a 50 paisa coins, so 50 paisa coins, this is first probability of an event A. So A is the number getting a 50 paisa coins. So that is number of 50 coins, that is the sample space, favorable outcome. So number of 50 paisa coins, that is n of A is equals to 100. So according to question, a piggy bank account contains 150 paisa coins, right? So here the number of 50 paisa coins is 100, that is n of A is equals to 100. So we know that the formula for probability, so probability of getting a 50 paisa coins, which is equals to number of favorable outcomes divided by total number of possible outcomes, right? So probability of getting a 50 paisa coins, which is equals to number of favorable outcomes divided by total number of possible outcomes. So that is P of A is equals to n of A divided by n of S. So P of A is equals to n of A, total n of A, that is number of 50 paisa coins, that is 100, whole divided by total number of possible outcomes, it is 180. So 0 gets cancelled, then remaining 10 by 18. Here 2 5s are 10 and 2 9s are 18. Hence the probability of getting a 50 paisa coins is 5 by 9. 50 paisa coins is 5 by 9. Hence the required probability of getting a probability of 50 paisa coin is 5 by 9. Okay. Then come to second sub question, that is a piggy bank account contains 150 paisa coins, 51 rupee coins, and 22 rupee coins, and 10 5 rupee coins. If it is equally likely that one of the coin will fall out when the bank is turned upside down, what is the probability that the coin will not be a 5 rupee coin, will not be a 5 rupee coin? So that we need to find, first of all, we need to find the probability that the coin will be a 5 rupee coin. So the probability of getting a 5 rupee coin, which is equals to, that is the second favorable outcome. So B is equals to number of 5 rupee coins. So here we know that so the number of 5 rupee coins is 10. The number of 5 rupee coins is 10. So that is n of B is equals to 10. That is n of B is equals to. Therefore, we know that so probability of getting a 5 rupee coin, that is P of B is equals to n of B divided by n of S. So probability of getting a 5 rupee coin is equals to number of favorable outcomes, so the divided by total number of samples. Here the number of favorable outcomes, so that is the number of the probability of getting a 5 rupee coin, so which is equals to P of B is equals to n of B, that is 10. So n of B, number of 5 rupee coins is 10 divided by total number of sample space, it is 180. So 0 gets cancelled, hence we get P of B is equals to 1 by 18. 1 by 18. 1 by 18. So is it clear to all children? Yes. So therefore we need to find a probability, right? Probability of not getting a, probability of not getting a 5 rupee coin, probability of not getting a 5 rupee coin. So that is P of E bar, right? So we know that yes, complementary, according to complementary events, so P of E plus P of E bar is equals to 1. So here P of E, that is probability of getting a coin. Probability of getting a 5 rupee coin is 1 by 18. 1 by 18. So this is 1 by 18 plus P of E bar not getting a 5 rupee coin, that is 1. So therefore P of E bar, which is equals to 1. So we can transpose this 1 by 18 from LHS to RHS. It becomes minus 1 by 18. So P of E bar is equals to 1 minus 1 by 18. So here we have different denominators, so that we should take yes, we should take LCM from denominator. So we get the LCM of 1 and 18 is 18. So here 18 ones are 18. So we can multiply 18 into the given numerator. So that is 18 ones are 18 minus here 18 ones are 18, and comparing the given LCM into the second denominator, that is 18 ones are 18, 1 ones are 1. Hence we get P of E bar is equals to 18 minus 1. We can subtract 1 from 18. We get 17 by 18, right? Hence we get the probability of not getting a 5 rupee coin is 17 by 18. Okay, I will continue in the next class. Thank you one and all children. Have a nice day.